Welcome students. Today we are going to study photochemistry, types of photochemical reactions, part 2. In part 1 already we started the types of photochemical reactions and we had an introduction and few photochemical reactions like photooxidation, photoaddition, photodissociation, photoreduction and photoisomerization. We'll be discussing these one by one. In the last video we discussed photoreduction. Now today we'll be discussing photoaddition reaction. So the most common example of photoaddition reaction is the Paterno-Bucci reaction. Carbonyl compounds yield oxytanes on irradiation in the presence of olefins. So here this is the reaction. Carbonyl compounds plus an olefin in presence of light yields oxytanes. Now this photocycloaddition is usually referred to as the Paterno-Bucci reaction. Since the addition is usually performed by irradiation with the light of wavelength absorbed only by the carbonyl group, it involves the excited state of the carbonyl compound rather than that of the olefin. We can say that it is the reaction between ground state of olefin and excited state, that is triplet state of carbonyl compound. In this reaction, there is addition of N-pi star triplet of ketone to alkene. Now let us see and understand the mechanism of this reaction. So here is the reaction written for you. So let us study this. Benzophenone, you can see benzophenone in ground state on irradiation. Singlet excited state of benzophenone is formed. Now this singlet excited state undergoes intersystem crossing ISC and triplet excited state of benzophenone is formed. Now this triplet excited state of benzophenone undergoes reaction with isobutene to form oxetane. And here this product which is formed is 90%. Since the olefin used in the above reaction is unsymmetrical, you can see here isobutene we have taken and it is unsymmetrical. So theoretically two products should arise from this cycloaddition. The other product is obtained only in 10% yield. And this product which is seen here in the equation is 90%. Now preferential formation of the major product indicates intermediacy of biradical, and logically the addition takes place to yield preferentially the most stable biradical intermediate first. The whole reaction occurs basically in two steps. The first step is the excited carbonyl compound in triplet state add through its oxygen atom to the olefin and form two biradical intermediates, that is first and second. The first biradical, you can see, is of 3 degree and is more stable than the second one. The second one is less stable. And so the product formed from the biradical, first one, is A, and that is 90%. While the product formed from the less stable biradical intermediate second is only 10%. And then in the second step, spin inversion takes place, second bond is formed, and cyclization leads to oxetane formation. So this is the complete mechanism of the reaction of benzophenone with isobutene yielding oxetane. So I hope you understood this mechanism. Now, moreover, irradiation of benzophenone with either cis or trans to butene yields the same mixture of both isomeric oxetanes. If it had been a concerted reaction in which both the bonds were formed simultaneously, then different products would have been formed in each case. The above result thus confirms intermediacy of a biradical A serious drawback of the Paterno-Beauty reaction is the competing energy transfer process from the excited ketone to the olefin in cases where the triplet energy of the former exceeds that of the later. Irradiation of acetone with norbornene second, for instance, yields dimer of norbornene rather than oxetanes. So this reaction is acetone sensitized photodimerization of norbornene. So in this reaction, you can see the equation written here and understand it. So acetone in the ground state, and the triplet energy of acetone is 78 kilocalories per mole. So on irradiation, acetone singlet excited state is formed, and this undergoes intersystem crossing to form triplet excited state of acetone. And this triplet excited state of acetone reacts with norbornene second, and the energy is transferred from acetone to norbornene, and acetone comes in ground state, and triplet excited state of norbornene is formed. Now this triplet excited state of norbornene forms dimer. So this is acetone sensitized photodimerization of norbornene. However, when a ketone having less triplet energy is used, for example, benzophenone, the triplet energy of benzophenone is 69 kilocalories per mole. So if benzophenone is used, then we get the oxetane of norbornene. So benzophenone plus norbornene on irradiation yields oxetane of norbornene. For similar reason, the Paterno-Beauty reaction fails to occur with conjugated dienes, whose triplet excitation energy is far below the triplet excitation energy of the ketones. So I hope you understood this reaction. So today we studied photoaddition reaction, a type of photochemical reaction. Thank you so much.